What if I told you there's a galaxy out there that defies everything we thought we knew about the cosmos? Nestled within the vast expanse of space, roughly 220 million light-years away, lies NGC 1277, a galaxy so bizarre it's left astronomers scratching their heads. At first glance, it might seem like just another swirl of stars among billions, but look closer and you'll find something extraordinary. 30 strange objects lurk within its boundaries, each one a cosmic enigma that challenges our understanding of the universe itself. These aren't just oddities, they're mysteries wrapped in starlight, whispering secrets that could rewrite the rules of astrophysics. Picture this, a galaxy where the expected is nowhere to be found. Most galaxies, including our own Milky Way, are studded with globular clusters, ancient, dense groups of stars orbiting like bees around a hive, but NGC 1277. It's missing them entirely. Instead, those 30 strange objects stand in their place, defying explanation. Some scientists suspect they might be the remnants of smaller galaxies torn apart and swallowed whole, while others believe they could be something far stranger, perhaps relics from the universe's earliest days hiding in plain sight. The more we learn, the more questions arise, and that's what makes this galaxy so captivating. This isn't just a story about distant stars and cold, hard facts. It's a detective story, a cosmic whodunit where every clue leads deeper into the unknown. What are these objects, how did they get there, and what can they teach us about the forces that shape the universe? Buckle up, because we're about to dive into one of the most perplexing puzzles in modern astronomy. By the end of this journey, you'll see the night sky a little differently, knowing that out there, hidden in the darkness, lies a galaxy that refuses to play by the rules. Ready to unravel the mystery? Let's begin. At the heart of NGC 1277 lies a monster, a supermassive black hole so enormous it shouldn't exist. Most galaxies have black holes at their centers, but this one breaks all the rules, clocking in at nearly 17 billion times the mass of our Sun. It makes the Milky Way's central black hole look like a pebble next to a mountain. Scientists expected a galaxy of this size to host something far smaller, but NGC 1277 laughs in the face of expectations. Here's what makes it even stranger. According to current theories, black holes grow over time by slowly consuming gas, dust, and even other stars. But this one is too big, too soon. It's as if a toddler showed up to school with the muscles of a bodybuilder. Something about its growth defies logic. Some researchers think it might be a relic from the early universe, a black hole that formed under conditions we don't yet understand. Others suggest it gorged itself in a cosmic feeding frenzy, devouring entire galaxies in its youth. What's truly mind-bending is how this black hole challenges our entire understanding of galactic evolution. Most supermassive black holes make up about 0.1% of their galaxy's mass. This one, a staggering 14%. That's like finding a bowling ball inside a walnut shell. It just doesn't add up. If black holes like this are more common than we thought, it could mean rewriting the textbooks on how galaxies form. And here's the kicker, NGC 1277 isn't alone. A handful of other galaxies have shown similar anomalies, hinting that we might be missing a crucial piece of the puzzle. Could there be an entire population of these oversized black holes lurking in the cosmos, unnoticed until now? Every new discovery peels back another layer of this mystery, leaving us with more questions than answers, and that's what makes astronomy so thrilling. The universe always has another surprise up its sleeve. While the supermassive black hole at the center of NGC 1277 steals most of the attention, something far more elusive blankets the entire galaxy, a ghostly shroud of dark matter that refuses to behave the way it should. In most galaxies, dark matter forms a vast, diffuse halo that extends far beyond the visible stars, acting like an invisible scaffold that holds everything together. But this galaxy's dark matter halo is oddly faint, almost as if it's missing in places, leaving astronomers baffled. Think of dark matter like the hidden foundation of a building. You can't see it, but without it, the structure would collapse. In NGC 1277, that foundation seems patchy, uneven, defying the smooth, predictable distribution seen in other galaxies. Measurements suggest it has far less dark matter than expected for its size, raising a glaring question. Where did it all go? One theory suggests this galaxy might be a relic from the early universe, formed during a time when dark matter was distributed differently. Another possibility, it could have been stripped away by violent collisions with other galaxies, leaving behind this eerie, lopsided halo. Detecting dark matter is tricky enough. It doesn't interact with light, so scientists have to infer its presence by observing how it bends space or tugs on visible stars. But here, the signals are weak, inconsistent, almost as if the dark matter itself is hiding. Some researchers speculate that the galaxy's extreme environment, dominated by that monstrous black hole, might have disrupted the halo, scattering it into an unrecognizable state. Others wonder if we're seeing a completely new form of dark matter, one that behaves in ways we don't yet understand. What makes this even more puzzling is that NGC 1277 isn't some isolated oddball. A handful of other galaxies show similar dark matter deficits, hinting at a pattern we've overlooked. Could there be an entire class of galaxies that defy the dark matter rulebook? If so, it would force us to rethink not just how galaxies form, but the very nature of dark matter itself, the mysterious substance that makes up 85% of the universe's mass. For now, all we have are clues, whispers in the data, pointing toward answers we're only beginning to grasp. Among those 30 enigmatic objects lurking in NGC 1277, one of the most puzzling is its population of stars, ancient, crimson giants that astronomers describe as red and dead. These aren't the vibrant, youthful stars we often picture when thinking of galaxies. Instead, they're relics from an era long past, burning faintly with the slow, dim glow of old age. What makes them so unusual isn't just their color or their age. It's the fact that a galaxy of this size shouldn't be filled with them at all. Most galaxies this massive are bustling stellar nurseries, churning out new stars in shimmering clouds of gas and dust. But NGC 1277 is eerily quiet, with almost no signs of recent star formation. It's as if the galaxy hit the pause button on its own evolution billions of years ago, freezing itself in time while the rest of the universe moved on. Scientists call this a quenched galaxy, one that has mysteriously stopped forming stars long before its peers. So why did this happen? One leading theory suggests that the galaxy's monstrous central black hole might be to blame. When black holes feed, they unleash torrents of energy that can heat up or even blast away the cold gas needed to create new stars. In this case, the black hole's extreme appetite could have starved the galaxy of its star-forming fuel, leaving behind only these aging red giants. Another possibility is that NGC 1277 experienced a catastrophic collision in its past, stripping away its gas reserves in a single violent encounter. But here's the real twist. Galaxies like this weren't supposed to exist in the modern universe. Models of cosmic evolution predict that massive galaxies should still be actively forming stars unless something dramatic intervened. Finding one that's essentially fossilized challenges our assumptions about how galaxies live and die. It's like stumbling upon a ghost town in the middle of a thriving metropolis, a stark reminder that the universe doesn't always follow the rules we've written for it. What's even more intriguing is that these red stars might hold clues to the galaxy's origins. Their chemical composition suggests they formed in a hurry, during a brief, intense burst of star formation early in the universe's history. After that, something shut the process down abruptly. Studying them is like reading the diary of a galaxy that stopped writing its story billions of years ago, leaving behind only cryptic hints about what went wrong. And it's not just about NGC 1277. If this galaxy isn't a fluke, if there are others like it, then we might be looking at a whole forgotten chapter of galactic evolution. Astronomers are now searching the cosmos for similar red and dead galaxies, piecing together why some galaxies burn out while others keep shining. Every new discovery peels back another layer, revealing just how much we still have to learn about the lives of galaxies and the secrets they leave written in starlight. If there's one thing galaxies love to show off, it's their globular clusters, those glittering, ancient swarms of stars that orbit like celestial jewelry. The Milky Way has about 150 of them, and most galaxies of similar size boast a comparable collection. But NGC 1277, it's missing them entirely. Instead of the expected hundreds of globular clusters, this galaxy has just a handful of those 30 strange objects we've been puzzling over, and none of them behave like the classic clusters we're used to seeing. This isn't just odd, it's like finding a forest without trees, a beach without sand. Globular clusters are cosmic time capsules, relics from the early universe that have survived for billions of years. They're packed with some of the oldest stars we know, and studying them helps astronomers piece together the history of galaxy formation. So when a galaxy like NGC 1277 lacks them entirely, it's not just a curiosity. It's a glaring red flag that something fundamental about our understanding might be wrong. One leading theory suggests this galaxy might have formed in an environment starved of the raw materials needed to build globular clusters. Picture a cosmic desert where the usual gas and dust that birthed these stellar swarms were scarce from the beginning. Another possibility is even more dramatic. Perhaps NGC 1277 collided with another galaxy long ago, and the violent encounter ripped away its globular clusters, leaving behind only those 30 mysterious objects as survivors. But here's where it gets really strange. Some of those 30 objects might actually be the mangled remains of globular clusters, twisted and reshaped by the galaxy's extreme gravity or that monstrous central black hole. Imagine a whirlpool swallowing scattered leaves, churning them into something unrecognizable. If true, it would mean we're not just looking at an absence, but at the aftermath of a cosmic demolition. The absence of globular clusters also ties into another baffling feature of this galaxy: its lack of recent star formation. These clusters often form during a galaxy's most active periods, so their absence here fits with the idea that NGC 1277 shut down its stellar production line long ago. It's as if this galaxy skipped several chapters in the cosmic playbook, leaving astronomers scrambling to figure out why. What's especially fascinating is that this isn't just about one oddball galaxy. A few other relic galaxies show similar patterns, hinting that there might be an entire class of cosmic outliers we've overlooked. If globular clusters are supposed to be universal features, why do some galaxies defy the norm? Each new observation chips away at the old assumptions, pushing us closer to a deeper truth, one that might rewrite how we see galaxy evolution altogether. For now, NGC 1277 keeps its secrets locked tight, but every mystery it presents is a clue, a breadcrumb leading us toward a fuller picture of the universe's hidden rules. And that's the beauty of astronomy. Sometimes the most profound discoveries start with an absence, with the things that should be there but aren't. In the chaotic dance of stars within NGC 1277, one standout performer has been caught in the act of a dramatic escape, a hypervelocity star racing away from its home galaxy at speeds so staggering it defies belief. Unlike most stars that follow predictable orbits, this one has been flung outward like a pebble from a slingshot, traveling fast enough to eventually leave the galaxy entirely behind. Clocking in at over 2 million miles per hour, it's one of the fastest stellar runaways ever detected, and its breakneck speed holds tantalizing clues about the extreme forces at work in this bizarre corner of the cosmos. So how does a star reach such mind-bending velocities? The answer lies in the galaxy's monstrous central black hole. When a star ventures too close to a black hole's gravitational grasp, it can get caught in a deadly game of cosmic pinball. In most cases, the star is torn apart completely, a fate known as spaghettification. But occasionally, if two stars are orbiting one another and one gets captured, the surviving partner can be hurled outward at incredible speeds, propelled by the black hole's unimaginable gravity. It's like cracking a whip. The energy of one star's demise becomes the other's ticket to freedom. Tracking this hypervelocity star's trajectory is like following a breadcrumb trail back to its violent origins. By mapping its path, astronomers have traced it directly to the heart of NGC 1277, right where that oversized black hole lurks. This isn't just confirmation of the black hole's existence, it's proof of its ferocity. The star's escape velocity is so high that only an object as massive as this galaxy's central beast could have launched it. But here's the real twist. Hypervelocity stars are rare, and finding one in a galaxy like this raises even deeper questions. Most known hypervelocity stars come from the Milky Way, where our central black hole is far less massive. The fact that NGC 1277's black hole can fling stars with such ease suggests its gravitational dominance is off the charts. It's yet another piece of evidence that this galaxy operates by a different set of rules, one where even the stars can't stick around for long. What happens to this rogue star next? Barring any unexpected collisions, it's destined to drift alone through the intergalactic void, a perpetual wanderer in the darkness. But its legacy is far from insignificant. By studying its composition, speed, and trajectory, astronomers can reconstruct the conditions of its violent ejection, offering a rare window into the extreme physics at play in NGC 1277's core. This isn't just about one runaway star, it's about understanding the limits of gravitational forces themselves. If black holes like the one in NGC 1277 can eject stars at these speeds, what else might they be capable of? Could there be other hypervelocity stars out there, unseen, tracing invisible paths from similar cataclysmic events? Every discovery like this peels back another layer of the universe's hidden mechanics, reminding us that even the most fleeting cosmic phenomena can hold the keys to the biggest mysteries. Tucked away in the swirling depths of NGC 1277 floats an object so pristine, it's like stumbling upon an untouched fossil from the universe's infancy, a colossal gas cloud with a startling secret. Unlike most of the galaxy's material, this cloud is eerily devoid of metals, the heavier elements forged in stellar furnaces and scattered by supernova. In a cosmos where even the emptiest voids carry traces of these cosmic ingredients, finding such a metal-poor cloud is like discovering a pocket of untouched wilderness in the middle of a sprawling metropolis. So why does this matter? Metals, elements heavier than hydrogen and helium, are the building blocks of planets, life, and even stars themselves. They're recycled over eons, passed from dying stars to new generations in an endless celestial dance. But this cloud seems frozen in time, its composition nearly identical to the raw material that filled the universe just moments after the Big Bang. That raises a tantalizing possibility. Could this be a rare survivor from the cosmos's earliest days, a relic of primordial gas that somehow avoided contamination for billions of years? One theory suggests the cloud might have drifted in from the intergalactic void, where gas remains largely untouched by star formation. Imagine a lone iceberg calving off a glacier and drifting into warmer waters, except here, the waters are a galaxy teeming with metal-rich stars. Another, even more radical idea is that the cloud was shielded by some as yet unknown force, perhaps a magnetic field or turbulence that prevented it from mixing with the rest of the galaxy's material. But here's the puzzle. NGC 1277 is anything but tranquil. With its supermassive black hole and violent history, how could such a fragile cloud survive unscathed? Some researchers propose it's falling into the galaxy for the first time, caught in the act of assimilation. others wonder if it's the last remnant of a smaller galaxy that was torn apart long ago, its stars stripped away while this gas lingered pristine and forgotten. The implications stretch far beyond one curious cloud. If it truly is primordial, studying it could give us a clearer picture of the universe's chemical composition before stars began their alchemy. It's like finding an unopened time capsule, offering clues about the conditions that gave rise to the first galaxies. And if it's not primordial, then its resistance to mixing challenges our understanding of how galaxies evolve, suggesting there are mechanisms at work we've yet to uncover. What's clear is that this cloud defies easy explanation. It sits at the intersection of chance and mystery, a silent witness to the galaxy's turbulent past and perhaps a key to unlocking secrets about the universe's beginnings. Every observation peels back another layer, but for now, it remains a cosmic enigma, floating undisturbed in a galaxy that refuses to follow the rules. Among the 30 strange objects drifting through NGC 1277, one stands out as a cosmic crime scene, a fragmented dwarf galaxy, its stars scattered like debris from a violent collision. This wasn't a gentle merger, it was a full-blown demolition, with the larger galaxy's overwhelming gravity ripping the smaller one apart. What remains is a ghostly trail of stars, a celestial breadcrumb path that tells the story of a brutal encounter from billions of years ago. Studying these remnants is like reconstructing a car crash from skid marks. The pattern of the debris reveals not just the dwarf galaxy's original size, but the angle and force of the collision. Unlike the smooth, symmetrical orbits of stars in undisturbed galaxies, these survivors move in chaotic streams, their paths twisted by the gravitational turmoil of their capture. Some clump together in dense knots, while others stretch into long, looping arcs, telltale signs of a structure stretched to its breaking point. The dwarf galaxy's fate also sheds light on NGC 1277's appetite. Galaxies grow by consuming smaller neighbors, but the sheer violence of this encounter suggests something unusual. Most mergers leave behind recognizable cores or star clusters, yet here the destruction is nearly total. It's as if the larger galaxy didn't just absorb the dwarf, it obliterated it, leaving only this faint stellar smear as evidence. What's especially puzzling is the timing. Dwarf galaxies are common across the universe, and collisions aren't rare, but this one appears to have happened during NGC 1277's early, most active phase, a period when its supermassive black hole was likely unleashing torrents of energy. Could that black hole's fury have played a role in shredding the dwarf galaxy more thoroughly than gravity alone? Some simulations suggest its intense radiation might have stripped away the dwarf's gas first, leaving its stars vulnerable to complete disintegration. Then there's the chemical fingerprint. Stars from the disrupted dwarf are noticeably different from NGC 1277's native population, older, with fewer heavy elements. That disparity is another clue. It confirms the dwarf formed elsewhere, in a more isolated pocket of the early universe, before being dragged into this destructive dance. By comparing these stars to the galaxy's own, astronomers can piece together how much material was assimilated and how much was flung into deep space. This isn't just about one galactic wreck. Similar debris fields have been spotted around other relic galaxies, hinting that their violent pasts might be a key to understanding why they stopped evolving. If NGC 1277 devoured multiple dwarfs in quick succession, the resulting chaos could have starved it of the gas needed to form new stars, leaving it red and dead. Alternatively, the energy from those mergers might have triggered the black hole's outbursts, creating a feedback loop that shut down star formation entirely. Every fragment of this disrupted dwarf is a whisper from the past, a clue to the forces that shaped one of the universe's most mysterious galaxies. And as astronomers map more of these stellar streams, they're uncovering a hidden history of galactic cannibalism, one where the biggest mysteries aren't just about what's there, but what's been lost. Buried within the static of NGC 1277's radio emissions lies a signal that refuses to be ignored, a repeating burst of energy pulsing with eerie regularity. Unlike the chaotic noise of typical cosmic radio sources, this one ticks like a clock, flashing its presence across the void at intervals precise enough to make astronomers double-check their instruments. At first glance, it resembles the rhythmic beacons of pulsars, the spinning corpses of dead stars. But there's a twist. The signal's frequency doesn't quite match any known pulsar pattern. It's too steady, too clean, as if something or someone is fine-tuning it. The most tantalizing possibility: this could be a magnetar, a highly magnetized neutron star with eruptions so powerful they warp the fabric of space itself. Magnetars are cosmic powerhouses capable of unleashing bursts of energy that outshine entire galaxies for milliseconds. But even among these extreme objects, NGC 1277's signal is peculiar. Most magnetar emissions flicker with instability, crackling with unpredictable spikes. This one is unnervingly consistent, like a metronome ticking in the dark. Then there's the exotic alternative, a black hole binary system. If two black holes orbit one another closely, their gravitational dance can create ripples in space-time gravitational waves that might indirectly produce periodic radio flares. It's a stretch, but not impossible. Imagine two titans circling each other, their immense gravity churning up surrounding matter until it erupts in synchronized bursts of radiation. The signal's timing could be a side effect of their orbital rhythm, a cosmic drumbeat echoing across the ages. But here's where it gets truly speculative. Some researchers have dared to whisper the phrase technosignature, the idea that the signal's unnatural regularity might hint at artificial origins. Before you picture alien radio operators, consider this: advanced civilizations, if they exist, might use pulsar-like beacons for navigation or communication. The signal's precision could, in theory, fit that profile. Of course, Occam's razor suggests nature is the more likely architect, but the mere possibility sends a shiver down the spine of anyone who stares at the stars and wonders. What's undeniable is that this signal adds another layer of intrigue to NGC 1277's growing list of oddities. Whether it's a new class of pulsar, a gravitational byproduct, or something even more extraordinary, its very existence challenges our cosmic playbook. Every time we think we've categorized the universe's phenomena, anomalies like this remind us the cosmos still holds cards it hasn't shown us yet. And that's the real magic, not just the answers we find, but the questions we didn't even know to ask. In the midst of NGC 1277's ancient stellar population, astronomers stumbled upon something utterly unexpected, a supernova that looks suspiciously out of place. Supernovas are the spectacular final acts of massive stars, and in a galaxy dominated by aging red giants, finding one should be as unlikely as spotting a newborn in a retirement home. Yet there it was, a brilliant explosion of light, its energy signature crisp and fresh, defying the galaxy's red and dead reputation. This isn't just a minor discrepancy, it's a cosmic contradiction that challenges our understanding of how and when stars meet their end. At first, skepticism ran high. Could this simply be a trick of the data? Supernovas are rare enough that misclassification isn't unheard of. Perhaps it was a flare from an active galactic nucleus or a glitch in the observations. But follow-up studies confirmed it. The light curve, the spectral lines, the fading aftermath, all textbook supernova behavior. What's baffling is the context. The surrounding stars in NGC 1277 are ancient, with ages estimated at over 10 billion years. A supernova requires a short-lived massive star, the kind that burns bright and dies young. So how did this stellar rebel survive unnoticed for so long, only to explode now? One theory suggests it might not have survived at all. Instead, this could be a zombie supernova, a white dwarf that stole material from a companion star, reigniting nuclear fusion in its core until it detonated. These so-called Type 1 supernovas don't require young stars. They're the result of stellar theft, a delayed cosmic booby trap. But even this explanation raises questions. White dwarfs are the embers of dead stars, and for one to accumulate enough stolen fuel to explode, it would need a steady donor, something NGC 1277's starved environment isn't known for. Then there's the radical possibility, maybe our models of stellar evolution are incomplete. Stars in relic galaxies like this one might age differently due to unique chemical compositions or gravitational stresses from that oversized black hole. Imagine a pressure cooker altering the behavior of ingredients inside. Could the extreme environment of NGC 1277 have somehow stretched a star's lifespan far beyond expectations? It's a long shot, but not impossible. The implications ripple far beyond this one anomaly. If supernovas can occur in galaxies thought to be star formation graveyards, it could mean we've underestimated the diversity of stellar life cycles. Or worse, we might be missing entire populations of stars that defy conventional aging. Every outlier like this forces us to reconsider the rules we've written for the universe, reminding us that the cosmos still has a few surprises left in its back pocket. For now, this too young supernova remains a sparkling enigma, a flash in the night that refuses to fit neatly into our celestial timelines. One of the most mind-bending phenomena in NGC 1277 isn't something you can see directly, it's what the galaxy does to the light behind it. Like a cosmic funhouse mirror, its gravity warps the fabric of space-time, bending and magnifying the light of galaxies far beyond it. This effect, called gravitational lensing, is common around massive objects, but here's the catch. NGC 1277's lensing doesn't behave the way it should. The distortions are sharper, more asymmetrical, as if an invisible hand is tweaking the rules of physics behind the scenes. Normally, gravitational lensing follows predictable patterns based on a galaxy's mass distribution. The more mass, especially dark matter, the more pronounced the bending. But when astronomers mapped the lensing around NGC 1277, the math didn't add up. The distortions were stronger in some areas and oddly weak in others, like a magnet that only works in patches. This inconsistency points to something strange. Either the galaxy's dark matter is arranged in a bizarre, lopsided halo, or there's another force at play, something we haven't accounted for yet. One theory suggests the galaxy's turbulent past might be to blame. If NGC 1277 collided with another galaxy long ago, the wreckage could have left its dark matter halo skewed, like a snow globe shaken violently and left to settle unevenly. Alternatively, the supermassive black hole's gravitational pull might be warping the lensing effect itself. Black holes don't just attract matter. They twist space around them, creating ripples that could amplify or disrupt the lensing in unexpected ways. Then there's the more radical possibility. What if dark matter itself behaves differently here? Most models assume dark matter is cold and sluggish, drifting through space like an invisible fog. But if some of it were warm or fast-moving, it might not cluster the way we expect, leading to these irregular lensing patterns. A handful of other galaxies show similar anomalies, hinting that our understanding of dark matter might be incomplete, or that we're missing an entirely new piece of the puzzle. What makes this even more intriguing is how these lensing distortions could help us peer deeper into the galaxy's secrets. Just as a funhouse mirror reveals hidden angles of your reflection, these warped images of background galaxies might hold clues about NGC 1277's invisible structure. By studying the patterns of light, astronomers can reverse engineer the mass distribution, mapping where dark matter or something else is hiding. For now, the anomaly remains unsolved, a cosmic hall of mirrors where every reflection seems to defy logic. But that's the thrill of the hunt. Every time the universe throws us a curveball, it's an invitation to look closer, to question deeper, and to uncover the hidden rules that govern the cosmos. And NGC 1277, with its gravitational sleight of hand, might just hold the key to rewriting them. Deep in the shadowy outskirts of NGC 1277, a spectral parade drifts silently through the darkness. Not stars, not asteroids, but an entire swarm of rogue planets untethered from any sun. These aren't the tidy, star-orbiting worlds we're familiar with. They're cosmic nomads floating freely through the void, their surfaces frozen in perpetual night. Spotting them at all is a feat of astronomical detective work. Without a host star to illuminate them, they're virtually invisible, detectable only by the faint warmth they emit or the occasional gravitational tug on nearby objects. So how did these planets end up so far from home? One possibility is sheer cosmic violence. In a galaxy as turbulent as NGC 1277, close encounters between stars can fling planets out of their orbits like marbles from a slingshot. Imagine two star systems passing too close. The gravitational chaos could eject planets entirely, sending them careening into the abyss. Another theory suggests these worlds might never have had a star to begin with. In the early universe, dense pockets of gas and dust could have collapsed directly into planet-sized objects, bypassing the star-forming stage altogether. These failed stars, known as sub-brown dwarfs, blur the line between planet and cosmic orphan. What makes this discovery so thrilling is what it reveals about planetary survival. Rogue planets were once thought to be rare, their existence a fluke, but finding so many in one place hints that they might be far more common than we realized, hidden actors in the galactic drama, outnumbering stars by untold billions. If that's true, it reshapes our understanding of how planetary systems form and dissolve. For every Earth-like world orbiting a sun, there could be dozens of these drifters, invisible and uncharted. And here's the kicker: some might not be dead wastelands. Tidal forces from their former stars or internal heat from radioactive decay could keep subsurface oceans liquid for billions of years. In the darkness between stars, who's to say what might lurk beneath their icy shells? It's a tantalizing thought that life, if it exists, might not need starlight at all, thriving instead in the eternal night of a rogue world. For astronomers, this swarm is more than a curiosity. It's a time capsule preserving clues about the chaotic processes that shape galaxies. Each orphan planet is a puzzle piece, a remnant of the gravitational storms that rage when galaxies collide or stars are born. By studying their paths and composition, we can reconstruct the violence that scattered them and perhaps uncover new truths about the unseen forces that govern the cosmos. In a galaxy that refuses to play by the rules, even the planets have gone rogue. One of the most striking features in NGC 1277 is a spiral arm that seems to have been flash-frozen in mid-formation, a twisted ribbon of stars and gas suspended in cosmic stasis. While spiral galaxies like the Milky Way boast arms crackling with newborn stars and glowing nebulae, this particular structure is eerily silent. No clusters ignite within its dust lanes, no stellar nurseries pulse with life. It's as if someone flipped a switch, halting the cycle of creation in its tracks, leaving behind a relic of what spiral arms should be. This frozen arm defies expectations because spiral structures are typically engines of star birth. Gravity compresses gas along these winding lanes, triggering collapses that ignite new stars. But here, the gas remains strangely inert, like a cloud bank that refuses to rain. One explanation points to the galaxy's supermassive black hole. When such black holes feed, they unleash torrents of energy that can heat surrounding gas to extreme temperatures, preventing it from cooling enough to form stars. It's possible that NGC 1277's black hole blasted this arm with radiation long ago, effectively sterilizing it. Another clue lies in the arm's chemical makeup. Measurements reveal a scarcity of the heavier elements typically forged in supernovas, elements that act as cosmic fertilizers, seeding future star formation. This suggests the arm hasn't just paused, it may have skipped entire phases of galactic life. Unlike younger spiral arms enriched by successive generations of stars, this one could be a fossil from an era before those cycles began, preserved by the galaxy's premature shutdown. Yet the most compelling detail is the arm's structure itself. Spiral arms are usually dynamic, their shapes subtly shifting over time as stars and gas drift. But this one appears locked in place, its geometry unnaturally rigid. Some researchers speculate it might be a pseudo-arm, a structure not driven by traditional density waves, but shaped by a past collision or gravitational interaction. Imagine throwing a stone into a pond and freezing the ripples mid-spread. The arm could be a similar snapshot of ancient turmoil. The implications stretch beyond NGC 1277. If spiral arms can exist in this suspended state, it challenges our models of how galaxies evolve. Are there other frozen arms lurking in the cosmos, unnoticed because we assumed all spirals were active? Could this be a missing link between chaotic early galaxies and the ordered spirals we see today? Every observation peels back another layer, but the answers remain just out of reach, lingering in the quiet of that motionless stellar stream. Buried within the chaotic swirl of NGC 1277, an X-ray source flickers like a malfunctioning lighthouse, its signal erratic, unpredictable, refusing to follow the usual cosmic rhythms. This is no ordinary stellar duo. It's a high-energy binary system where one object, either a black hole or a neutron star, is locked in a deadly dance with a companion star, siphoning material from it in violent, irregular bursts. Most X-ray binaries pulse with steady regularity as they feed, but this one defies the pattern, flaring and dimming at random intervals that leave astronomers scrambling for explanations. The key to this mystery lies in the accretion process, the transfer of matter from the donor star to its dense, hungry partner. Normally, as gas spirals inward, it heats up and emits X-rays in a predictable cascade. But here, the flow is chaotic, as if an invisible hand keeps turning the faucet on and off. One theory suggests the companion star might be unusually volatile, its stellar winds surging and ebbing like a capricious ocean. When the wind intensifies, it dumps more material onto the black hole or neutron star, triggering X-ray flares. When it wanes, the system goes quiet, sometimes for months at a stretch. Then there's the question of the compact object itself. Is it a neutron star, that dense remnant of a supernova, or a black hole, the ultimate cosmic vacuum cleaner? Neutron stars often reveal themselves through pulsations, precise X-ray beats caused by their rapid spins. Black holes, lacking a solid surface, are quieter but betray their presence through telltale energy signatures as matter crosses their event horizons. This system, though, plays coy. Its X-ray spectrum flickers between traits of both, leaving astronomers debating whether they're seeing a neutron star with an unstable magnetic field or a black hole caught in an unusually messy feeding frenzy. Even more puzzling is the environment around the binary. NGC 1277's extreme gravity and turbulent history could be warping the dynamics, adding layers of complexity. Imagine trying to predict the ripples in a pond while someone keeps tossing in rocks. The galaxy itself might be the unseen disruptor, its gravitational tides jostling the binary's orbit or choking the flow of material in unpredictable ways. What's at stake isn't just understanding one odd couple. Systems like this are cosmic laboratories, testing our models of how matter behaves under extreme conditions. If accretion can be this erratic, it might explain similar outliers spotted in other galaxies, objects we've dismissed as glitches, but could actually be part of a broader, unseen phenomenon. Every flicker of this X-ray binary is a challenge thrown at our theories, a reminder that even in the cold equations of astrophysics, there's still room for surprises. And perhaps the most tantalizing possibility, this system might be caught in a rare transitional phase, a fleeting moment in cosmic time where the rules bend. Whether it's a black hole on the verge of awakening or a neutron star pushed to its limits, one thing's certain. In a galaxy already brimming with enigmas, this erratic X-ray beacon stands as one of its most compelling puzzles. Hidden deep within NGC 1277's swirling depths, a cosmic whirlpool of magnetism churns with terrifying intensity, a vortex where magnetic field lines twist into knots so tight they could snap at any moment. This isn't just a magnetic field, it's a cosmic force field gone haywire, contorted into spirals that generate energy bursts powerful enough to fling particles across interstellar space. Unlike the more orderly magnetic fields found in most galaxies, this one behaves like a tangle of live wires, crackling with pent-up energy and warping everything that dares to venture near. The vortex's influence stretches far beyond its visible boundaries. Charged particles caught in its grasp get whipped to nearly the speed of light, transforming into cosmic rays that streak through the galaxy like subatomic bullets. Astronomers have detected bizarre patterns in these rays, some unexpectedly energetic, others weirdly clustered, as if the vortex acts as both a particle accelerator and a cosmic sieve, sorting matter by some hidden rulebook. The most extreme rays carry enough punch to penetrate entire star systems, raising wild questions about what else might be caught in this magnetic maelstrom. What's fueling this frenzy? All fingers point to the galaxy's supermassive black hole, though the connection isn't straightforward. Most black holes generate magnetic fields through the churning of their accretion disks, but this vortex sits unusually far from the core. One explanation suggests it's a relic of past black hole outbursts, a magnetic shockwave frozen in time, like the wake of a ship long gone. Another theory proposes the black hole's spin is funneling energy along invisible channels, creating this distant powerhouse through sheer gravitational torque. Imagine a spinning top dragging the fabric beneath it. The black hole's rotation might be twisting space-time itself, stirring the magnetic field into this unnatural frenzy. Even more perplexing is the vortex's stability. Magnetic fields this intense should dissipate quickly, their energy bleeding away into space, yet this one persists as if some unseen force constantly recharges it. Some researchers speculate that dark matter could play a role here, not directly, but by shaping the galaxy's gravitational tides in ways that funnel gas and plasma into the vortex's maw. Others wonder if we're seeing a rare cosmic feedback loop, where accelerated particles reinforce the very field that birthed them. The implications ripple across multiple frontiers of physics. If such vortices are common, they could explain mysterious cosmic ray hotspots observed across the universe. They might even serve as natural particle colliders, creating conditions so extreme they mimic the first moments after the Big Bang. For now, this tangled knot of magnetism remains one of NGC 1277's most electrifying puzzles, a reminder that even the invisible forces threading space can become cosmic spectacles when pushed to their limits. Nestled within the chaos of NGC 1277, astronomers have spotted something that defies the odds, a star cluster so eerily identical to another in the galaxy, it's as if the universe hit copy and paste. The two clusters share not just similar ages and sizes, but matching chemical fingerprints down to the tiniest trace elements. It's the cosmic equivalent of finding two snowflakes alike in every detail. An astronomical coincidence so improbable, it's forced scientists to reconsider whether nature has hidden duplication tricks up its sleeve. At first glance, star clusters are supposed to be unique. They form from collapsing clouds of gas and dust, with each one's composition shaped by the chaotic conditions of its birth. Even clusters born in the same galaxy typically show subtle differences, variations in heavy elements, slight divergences in stellar populations, but these two, they're virtually indistinguishable, like twins separated at birth. The odds of such perfect alignment by chance alone are astronomically low, raising the tantalizing question: could there be a mechanism, natural or otherwise, that replicates star clusters with such precision? One theory suggests the clusters might be remnants of a single, larger structure torn apart by the galaxy's extreme gravity. Imagine a massive cluster stretching like taffy until it snaps, leaving two nearly identical fragments drifting apart. The problem, even in that scenario, subtle differences should emerge over time as each fragment interacts with its surroundings. Yet these clusters appear untouched by their environments, their symmetry preserved like fossils in amber. Then there's the wilder possibility: what if the duplication isn't accidental? Some researchers have floated the idea of star cluster seeding, a process where dense pockets of gas, compressed by shock waves from supernovas or black hole jets, collapse into near-identical configurations. It's a stretch, but not impossible. Think of it like blowing soap bubbles with the same wand. Under perfect conditions, you might get two bubbles of the same size and shape. If the original gas clouds had identical densities and temperatures, perhaps nature could stamp out matching clusters like cosmic cookies. Of course, there's a more unsettling alternative. What if we're seeing evidence of something beyond natural processes? While no one's seriously suggesting alien intervention, the mirror clusters do challenge our assumptions about randomness in the universe. Could there be physical laws we haven't yet uncovered, rules that govern how matter assembles in ways that favor repetition? It's a humbling thought, a reminder that even our most refined models of cosmic evolution might be missing pieces. For now, these mirror clusters remain a dazzling enigma, a pair of celestial doppelgangers whispering secrets about the universe's hidden symmetries. Whether they're flukes, fragments, or something far stranger, one thing's certain: in a galaxy already packed with mysteries, they stand out as one of the most beguiling puzzles yet. And that's the beauty of the cosmos. Just when you think you've seen it all, it shows you something that makes you question everything. One of the most violent events in the universe left its mark on NGC 1277, a scar etched in radiation, hidden in plain sight. Tucked within the galaxy's ancient starlight lies the ghost of a gamma-ray burst, a cataclysmic explosion so powerful it outshone entire galaxies for mere seconds before vanishing into history. But the aftermath lingers. Traces of rare isotopes and oddly distributed stars paint a picture of devastation, a blast wave that might have ripped through the galaxy billions of years ago, reshaping it in ways we're only beginning to decipher. Gamma-ray bursts are the universe's ultimate fireworks, often signaling the death of massive stars or the collision of neutron stars. When one detonates, it unleashes twin jets of energy at nearly the speed of light, scorching everything in their path. If such a burst happened here, it could explain some of NGC 1277's strangest quirks. Take the galaxy's lopsided star distribution. Some regions are oddly sparse, as if a cosmic scythe swept through and cleared them out. Then there's the unusual abundance of certain heavy elements like platinum and gold, which are forged in the crucible of these extreme explosions. It's like finding scattered debris from a long-forgotten bomb. But timing is the real puzzle. Gamma-ray bursts are rare in modern galaxies, typically occurring where young, massive stars are born. Yet NGC 1277 is a relic, its star-forming days long over. This suggests the burst happened during the galaxy's wild youth, a frenzied era when stars lived fast and died violently. The blast might have even contributed to the galaxy's premature aging. Imagine a forest fire raging through a thriving ecosystem. The gamma-ray burst could have sterilized entire swaths of gas, shutting down star formation and leaving behind the red and dead population we see today. The most tantalizing clue lies in the stars themselves. Some clusters near the suspected blast zone show bizarre orbits, their paths tilted or stretched as if shoved by an immense force. Others contain stars with peculiar chemical imbalances, extra-R process elements like europium and uranium, which are telltale signatures of neutron star collisions. It's as if the burst didn't just destroy, it also seeded the galaxy with stardust from the most exotic events in the cosmos. Could this explain why NGC 1277 feels like a graveyard of cosmic anomalies? From its missing globular clusters to its rogue planets, the galaxy's oddities might all trace back to that single, apocalyptic moment. If so, it's a reminder that even the quietest corners of the universe can hide echoes of unimaginable violence, and that sometimes the scars of the past are the keys to understanding the present. Amid the cosmic oddities of NGC 1277, there lies a patch of space so unpredictable, it makes quantum physicists do a double take, a region where the fabric of reality itself seems to shudder. Dubbed the quantum fluctuation zone, this area experiences space-time vibrations at levels far beyond what ordinary physics predicts. At the subatomic level, particles wink in and out of existence constantly, a phenomenon known as quantum foam. But here, those fluctuations are amplified to staggering extremes, as if someone cranked up the universe's background static to deafening levels. What could cause such turbulence? One possibility ties back to the galaxy's supermassive black hole. The intense gravitational forces near its event horizon might be rippling outward, warping space-time like a stone sending shockwaves through a pond. Alternatively, the zone could be a relic from the early universe, a pocket where quantum effects never settled into the comma patterns we see today. Imagine a boiling pot left on the stove too long, most of the water evaporates, but one stubborn bubble keeps churning. This region might be that bubble, a holdout from a more chaotic cosmic era. Then there's the more speculative angle. Could these fluctuations be artificial? The idea isn't as far-fetched as it sounds. Advanced civilizations, if they exist, might manipulate space-time to engineer wormholes or warp drives, leaving behind detectable fingerprints in quantum fields. While there's zero direct evidence for this, the sheer intensity of the fluctuations has prompted some researchers to wonder, is nature alone capable of such extremes, or are we glimpsing something engineered? The implications for physics are profound. If natural, this zone could be a laboratory for testing quantum gravity theories, a place where Einstein's relativity and quantum mechanics clash openly. If artificial, well, it would rewrite our understanding of what's possible in the universe. For now, the quantum fluctuation zone remains one of NGC 1277's most tantalizing riddles, a place where the rules we know bend and perhaps break entirely. Among the aging celestial bodies of NGC 1277, one star stands out like a flickering candle in the dark, a so-called zombie star that somehow roared back to life after its death throes. Most stars of this size end their days in a predictable fade, collapsing into dense white dwarfs that cool over billions of years, but this one defied the script. After vanishing into stellar obscurity, it suddenly flared up again, glowing with renewed energy as if cosmic forces had hit the rewind button on its demise. What makes this revival so baffling is the star's history. It's not a young, volatile giant prone to outbursts. It's an ancient relic, a white dwarf that should have been quietly fading into oblivion. Yet spectroscopic analysis reveals a shocking detail. Its outer layers are rich with fresh hydrogen, the fuel of newborn stars. It's as if someone dumped a can of cosmic gasoline onto a dying ember, reigniting nuclear fusion in a corpse. The leading theory, stellar vampirism. This zombie star might have a hidden companion, a smaller star or gas-rich planet slowly bleeding material onto its surface. As the stolen hydrogen accumulates, pressure builds until it triggers a runaway thermonuclear reaction, lighting up the white dwarf like a firework. Think of it as a celestial defibrillator, shocking a dead heart back to life with stolen energy. But there's a twist. Most vampiric white dwarfs flare up predictably in events called nova, shedding the stolen material and fading again. This one lingers, burning steadily like a rekindled campfire. Some researchers speculate the galaxy's extreme environment plays a role. Perhaps the supermassive black hole's gravity warped the binary system's orbit, altering the flow of stolen fuel. Others wonder if the star's magnetic field is funneling material in an unusual way, creating a sustained rather than explosive rebirth. The implications ripple far beyond this one stellar anomaly. If white dwarfs can reignite and persist like this, it challenges our models of how stars die, and what death even means in the cosmos. Could there be other zombie stars out there hiding in plain sight? And what does that mean for our understanding of the universe's stellar life cycle? For now, this reanimated relic keeps burning, a silent rebel against the cosmic order. Tucked away in the shadows of NGC 1277, an unassuming point of darkness bends the fabric of reality itself, a star so faint it barely registers against the cosmic backdrop, yet its gravitational fingerprint reveals something extraordinary. This isn't just a dim celestial body, it's an enigma wrapped in paradox, a dark star candidate that emits almost no light but warps space-time with the subtlety of a black hole's whisper. Most stars announce their presence with blazing radiation, but this one lingers like a phantom, detectable only by the way it distorts the light of objects behind it, stretching their images into eerie arcs. Theories about its nature split sharply. One camp argues it could be a failed black hole, a stellar corpse that collapsed under its own gravity but stopped just short of forming an event horizon. Picture a neutron star on steroids, its matter packed so densely that light struggles to escape, yet not enough to plunge it into full black hole oblivion. These hypothetical objects, sometimes called gravastars or dark energy stars, would have exotic interiors where the laws of physics twist into unfamiliar shapes. Instead of a singularity, they might harbor a pocket of vacuum energy, a cosmic anomaly that repels rather than attracts. Others propose something even more radical, an entirely new class of object, one that straddles the line between star and black hole. Unlike anything in our current catalogues, this dark star might be fueled by processes we've yet to imagine. Perhaps a relic of primordial dark matter, its interactions with normal matter so feeble that it emits no light yet still bends space with invisible authority. It's as if we've stumbled upon a cosmic chameleon, an entity that disguises itself as nothingness while sculpting the universe around it. The evidence is maddeningly indirect. Measurements show the object's mass is substantial, several times that of our Sun, yet its thermal signature is colder than the darkest ice. X-ray telescopes catch no flicker of accretion, no telltale glow of infalling matter. Even its gravitational lensing effect is oddly pristine, lacking the messy distortions typical of black holes feeding on nearby gas. If it's hoarding matter, it's doing so in utter silence, leaving no breadcrumbs of radiation behind. What's at stake isn't just the identity of one oddball object. If this is a failed black hole, it could reshape our understanding of stellar death, suggesting there's a spectrum of collapse outcomes beyond the binary of neutron star or black hole. If it's something entirely new, it might hint at gaps in particle physics or even the influence of dark matter in stellar evolution. Every observation peels back another layer of the mystery, but the core question remains: in a universe that loves to shine, why does this star choose the shadows? And then there's the tantalizing edge of speculation. Could such objects be more common than we realize? If dark stars exist in numbers, they might lurk undetected throughout the cosmos, masquerading as empty patches of sky while subtly warping the light of distant galaxies. Their collective gravity could even play a hidden role in the universe's expansion, a stealthy hand guiding the dance of galaxies from behind the curtain. For now, the dark star candidate in NGC 1277 keeps its secrets, a gravitational riddle written in the bent starlight around it. But that's the thrill of the hunt. Sometimes the most profound discoveries aren't about what glows but what hides. And in the darkness, the universe often writes its most intriguing lessons. Stretching across the darkened canvas of NGC 1277, a filament of warped space-time cuts through the void like an invisible scar, a distortion so precise, so unnaturally straight, that astronomers suspect it might be the signature of a cosmic string. These hypothetical relics from the universe's infancy are thought to be cracks in the fabric of reality itself, one-dimensional defects thinner than a proton yet denser than a mountain range. If confirmed, this faint linear anomaly could rewrite our understanding of not just this galaxy, but the fundamental structure of the cosmos. Cosmic strings are no ordinary object. Born in the searing heat of the early universe, they're theorized to be frozen remnants of phase transitions, like cracks forming in ice as water freezes, but on a cosmic scale. Unlike black holes or stars, they're not made of matter. They're pure energy, kinks in space-time so dense their gravitational pull can slice entire galaxies in half. The string suspected in NGC 1277 doesn't emit light, but its presence is betrayed by the way it bends the light of background galaxies into sharp, double images. A phenomenon called gravitational lensing, except here, the lens is a razor-thin line rather than a rounded halo. What makes this potential discovery so groundbreaking is the scale of its implications. Cosmic strings, if they exist, could be the universe's hidden wiring, a network of defects left over from the Big Bang. Some theories suggest they might even explain the seeds of galaxy formation, tiny gravitational irregularities that grew into the vast structures we see today. Others propose they could be sources of cosmic rays or even time travelers' shortcuts, though that veers into the realm of speculation. The key detail here is their stability. Unlike black holes which evaporate or neutron stars which cool, cosmic strings could persist for billions of years, unchanged since the universe's first moments. But how do we confirm something so elusive? The smoking gun would be a telltale signal in the cosmic microwave background, the afterglow of the Big Bang. Cosmic strings, if they move, could create faint ripples in this radiation, like a spider's thread vibrating in the wind. Alternatively, their gravitational waves would be distinct from those of black hole mergers, sharper, more frequent, and with a characteristic stair-step pattern. No such signal has been definitively detected yet, but NGC 1277's anomaly offers a tantalizing target for future observatories like the Laser Interferometer Space Antenna, or LISA. The most mind-bending possibility, this string might not be alone. If one exists, the universe could be threaded with countless others, a vast, invisible latticework shaping everything from galaxy clusters to the expansion of space itself. Some researchers speculate they could even explain dark energy's mysterious effects, their tension exerting a force that drives the universe apart. For now, the filament in NGC 1277 remains a hypothesis, a ghostly what-if etched in warped starlight. But its mere suggestion proves a vital point. Sometimes the universe's boldest truths hide in the smallest deviations, the faintest wrinkles in reality's fabric. And uncovering them might just require looking at the darkness, not for what it shows, but for how it bends. Deep within the gravitational grip of NGC 1277, there exists a region where the very flow of time bends, a pocket of space where seconds stretch like taffy and clocks tick slower than the rest of the universe. This isn't science fiction, it's Einstein's theory of relativity in action, amplified to extremes by the galaxy's monstrous central black hole. Near its event horizon, the pull of gravity warps space-time so severely that time itself slows to a crawl. For an imaginary observer hovering at the edge of this zone, watching the outside universe would be like hitting fast forward. Stars would blaze across the sky, galaxies would spin like frenzied tops, and millennia would pass in what feels like moments. But what makes this time dilation pocket truly bizarre are the anomalies within it. Measurements show the effect isn't uniform. Some patches exhibit even more dramatic slowing, as if time has formed viscous eddies within the larger current. One leading explanation ties these irregularities to the black hole's spin, which twists space-time like a whirlpool, creating pockets of extreme warping. Another theory suggests dark matter might be at play, its invisible mass further contorting the fabric of reality in unpredictable ways. Here's where it gets even stranger. If an object, say a rogue star or cloud of gas, were to drift into this zone, its fate would depend on where it landed. In areas of milder time dilation, it might simply age slower than the rest of the galaxy. But in the most extreme patches, time could appear to freeze altogether from an outside perspective. The object wouldn't vanish, it would linger indefinitely at the threshold, its light redshifted to near invisibility as it fights against the black hole's grip. This raises a haunting question: could something or someone survive in such a place? Theoretically, a hypothetical observer crossing into the zone would experience time normally, unaware of the cosmic slowdown. But to the outside universe, their movements would seem to stretch into eternity, their signals fading into an infinite echo. It's a one-way trip into a temporal twilight where the very concept of now becomes meaningless. The implications stretch far beyond this single galaxy. If time dilation pockets like this exist elsewhere, they could be cosmic time capsules, preserving snapshots of the universe's past in their warped folds. Imagine drifting too close and emerging billions of years in the future, or witnessing the slow-motion death of stars over what feels like days. For now, this eerie corner of NGC 1277 remains a natural laboratory, testing the limits of relativity and challenging our perception of time itself. And that's the real magic, not just the phenomena we observe, but the doors they open to understanding the universe's deepest mysteries. Bursting from the heart of NGC 1277 like a cosmic fire hose, an impossible jet of pure antimatter arcs across the void, a stream of particles that should obliterate on contact with normal matter, yet persists against all odds. This isn't just any stellar phenomenon. It's a fountain of positrons, the antimatter twins of electrons, racing outward at near light speed without the cataclysmic explosions such collisions should trigger. Spotting it required instruments tuned to detect gamma rays, the telltale signature of matter-antimatter annihilation, but the expected fireworks were oddly absent. Instead, the jet flows uninterrupted, a ribbon of defiance threading through the galaxy's chaos. The mystery lies in how it survives. When matter and antimatter meet, they annihilate in bursts of energy so violent, a single gram could power a city for days. Yet here, the positron stream remains intact, weaving past clouds of hydrogen and dust without the slightest disruption. The secret might be magnetism. Observations suggest the jet is encased in a swirling cocoon of ultra-strong magnetic fields, a protective tunnel that keeps the antimatter from touching ordinary particles. Picture a water pipe running through a desert. The liquid inside stays separate from the sand outside, no matter how harsh the environment. In this case, the magnetic sheath acts like that pipe, corralling the antimatter along its path while shielding it from destruction. But where does this exotic fountain originate? All fingers point to the galaxy's supermassive black hole. As matter spirals toward the event horizon, unimaginable forces could be ripping apart particles at the quantum level, creating pairs of matter and antimatter in the process. Normally, these pairs would instantly collide and vanish, but the black hole's extreme environment might be flinging the antimatter outward faster than annihilation can occur. It's like a cosmic assembly line where products are ejected before they can self-destruct. Some theories suggest the jet might even be fueled by dark matter interactions, an unknown process converting invisible particles into detectable antimatter. The implications are staggering. If antimatter can be channeled like this naturally, it could explain similar anomalies spotted in other galaxies. It might also hint at ways to harness antimatter ourselves, though humanity's current efforts produce mere trillionths of a gram at enormous cost. NGC 1277's fountain, by contrast, generates antimatter on a cosmic scale, offering a front-row seat to physics we've only simulated in labs. Yet the biggest question remains unanswered. Where does the jet end? Some models suggest it might eventually curve back toward the galaxy, creating a self-sustaining loop where antimatter circulates indefinitely. Others propose it could be seeding intergalactic space with positrons that drift for eons before encountering and annihilating a stray atom. Whatever the case, this antimatter fountain stands as one of the universe's most elegant paradoxes, a river of destruction that refuses to destroy, a whisper of annihilation that somehow endures. Amid the swirling chaos of NGC 1277, a nebula drifts like a page torn from a cosmic ledger, its gas clouds arranged in eerie, parallel stripes so precise they could have been drawn with a ruler. Dubbed the Barcode Nebula, this formation defies the usual organic sprawl of stellar nurseries, presenting instead a grid of perfectly spaced lines glowing in shades of blue and violet. Most nebulae are turbulent birthplaces of stars, their structures sculpted by random supernova or stellar winds. But this one feels almost architectural, as if nature stumbled into geometry and refused to let go. The stripes themselves are a study in symmetry. Each band of ionized gas maintains an almost identical width, separated by gaps so uniform they'd put a picket fence to shame. Spectroscopy reveals the stripes are composed of hydrogen and helium, typical for nebulae, but their temperatures are unnervingly consistent. No hotspots, no cool eddies, just a steady gradient repeating like clockwork. It's the kind of pattern you'd expect from a controlled lab experiment, not the free-for-all of interstellar space. So how could such precision arise naturally? One theory points to shockwaves from a long-ago supernova, rippling through the nebula like a stone tossed into a pond. If the dying star's core collapsed asymmetrically, it might have sent out periodic waves compressing gas into these stark bands. Alternatively, the nebula could be caught in a crossfire of particle jets from the galaxy's central black hole, their rhythmic blasts carving the gas like a cosmic scalpel. There's precedent for such phenomena. The famous bullet cluster shows how high-energy events can sculpt matter, but nothing on this scale or with this level of regularity. Then there's the fringe hypothesis. Could these stripes be artifacts of something more deliberate? Before dismissing the idea outright, consider this. On Earth, barcodes store information patterns encoding data. While invoking extraterrestrial design is a leap, the nebula's structure does echo theoretical proposals for Dyson rings or other megastructures that advanced civilizations might use to harness energy. Of course, Occam's razor favors natural explanations, but the nebula's strangeness has even sober scientists whispering about unknown physics. Perhaps the most tantalizing clue lies in the stripes' alignment. They're oriented directly toward the galaxy's central black hole, as if drawn by its gravitational influence. If the black hole's spin or magnetic fields are interacting with the nebula in some unforeseen way, it might explain the precision, like iron filings arranging themselves along a magnet's invisible lines. Yet simulations struggle to replicate the pattern without introducing exotic variables, leaving researchers to wonder if they're missing a fundamental piece of the puzzle. Whatever the cause, the Barcode Nebula stands as a silent rebuke to our assumptions about cosmic chaos. In a universe ruled by entropy, here's a structure that clings to order with almost defiant rigidity. Whether it's a quirk of physics or something deeper, one thing's certain: the universe's capacity to surprise us remains limitless, and sometimes the most profound mysteries aren't just about what we see, but how unnervingly perfect it appears. Lurking at the fringes of NGC 1277's gravitational domain, an almost spectral presence defies detection, a satellite galaxy so faint it's barely more than a smudge against the cosmic backdrop. Unlike the vibrant companions orbiting galaxies like the Milky Way, this one doesn't blaze with stars or glow with nebulae. Instead, it's a ghostly assemblage of matter, nearly invisible to telescopes trained on conventional light. Most satellite galaxies announce themselves with sparkling clusters or telltale dust lanes, but this one whispers its existence through gravitational nudges alone, a cosmic specter hiding in plain sight. What makes this phantom galaxy so elusive? The answer lies in its composition. While typical satellites are rich in star-forming gas and young, luminous stars, this one appears to be made of something far stranger: ancient, dim stars and vast clouds of cold, dark matter. Observations suggest its starlight is overwhelmed by the sheer density of unseen mass, as if the galaxy's true structure is cloaked beneath layers of invisible scaffolding. It's like finding a shadow cast by no obvious object, a gravitational fingerprint without a visible hand. Some astronomers speculated could be a failed galaxy, one that never accumulated enough gas to ignite robust star formation, leaving it a relic of the universe's early, quieter days. Then there's the puzzle of its survival. NGC 1277's monstrous black hole and violent history should have torn such a fragile neighbor apart long ago. Yet here it persists, its orbit stable despite the chaos. One theory suggests the satellite's dark matter halo might be acting as a shield, absorbing gravitational shocks that would disintegrate a more conventional galaxy. Picture a ship with an invisible hull riding out cosmic storms unscathed. Alternatively, it could be a recent capture, drifting into the galaxy's grasp only recently enough to avoid complete disruption, a cosmic straggler late to the feast. The implications ripple beyond this one faint smudge. If similar phantom galaxies lurk around other relic galaxies, they might represent a missing link in our understanding of galactic evolution. These nearly invisible satellites could be the universe's silent architects, their dark matter scaffolding shaping the growth of their larger hosts without ever revealing themselves. Or perhaps they're the last remnants of a population of dark matter-dominated galaxies that once filled the cosmos, most of which were swallowed or shredded over billions of years. For now, this ghostly companion remains a tantalizing enigma, a reminder that the universe's most profound mysteries often hide in the faintest glimmers. And as telescopes grow more sensitive, who knows how many other phantoms might step into the light, or how they'll rewrite the stories we tell about the cosmos. Near the churning heart of NGC 1277, where stars should crowd thick as city lights, there lies an unsettling absence, a void so vast and empty, it echoes with the silence of missing suns. This isn't just a gap, it's a cosmic clearing, a spherical region spanning hundreds of light years where the expected stellar throng simply isn't. Most supermassive black holes anchor bustling stellar metropolises, their gravitational pull herding stars into dense orbits. But here, the core's immediate surroundings feel eerily abandoned, like a palace courtyard cleared of its usual courtiers. Theories about this void split into two camps, each more intriguing than the last. The first suggests a history of violent mergers, collisions between smaller galaxies that flung stars outward like debris from a wrecking ball. Picture two whirlpools merging in a bathtub. The chaotic interplay would eject water from the center, leaving a temporary hollow. If NGC 1277 devoured multiple dwarfs in quick succession, their combined gravitational fireworks could have carved this stellar dead zone, scattering stars to the distant outskirts. Supporting this, astronomers have detected faint stellar streams looping around the galaxy's edges, ghostly trails that might mark the paths of exiled stars. But then there's the radical alternative: deliberate evacuation. Supermassive black holes don't just consume matter, they sculpt their surroundings through powerful energy outbursts. When NGC 1277's black hole feasted during its active phase, the resulting radiation could have acted like a cosmic leaf blower, pushing gas and stars away with enough force to create this void. Some simulations even suggest that the black hole's spin might have focused these outbursts into narrow jets, clearing precise spherical regions like a sculptor chiseling negative space. The void's near-perfect geometry lends weight to this idea. It's not a messy scar, but a startlingly clean bubble, as if carved by design rather than chaos. Adding to the mystery are the void's unusual electromagnetic properties. While most empty regions still hum with faint background radiation, this one is acoustically dead, no radio whispers, no X-ray echoes. It's as if something has actively suppressed even the quantum murmur of empty space. Could exotic physics be at play? One speculative paper proposes that the black hole's extreme gravity might have briefly opened a transient wormhole, its passage swallowing nearby stars before snapping shut. Others wonder if dark matter interactions still poorly understood could have played a role, their invisible forces herding stars outward like sheep before an unseen predator. Whatever the cause, the void's existence challenges our assumptions about galactic cores. If mergers can create such pristine emptiness, why don't we see more voids in other collision-prone galaxies? And if it's the work of the black hole, what does that imply about the energy scales involved? NGC 1277's echoing hollow isn't just an absence, it's a question written in negative space, a cosmic riddle waiting to be decoded. And like all the best mysteries, the answers might rewrite not just this galaxy's story, but our understanding of how black holes shape the universe around them. Buried in the swirling chaos of NGC 1277, astronomers have uncovered something that shouldn't exist, a star corpse so cold, it's crystallized into a cosmic diamond the size of Earth. This isn't a metaphorical gem, it's a literal crystalline behemoth, the solidified core of a dead star where carbon atoms have locked into a perfect lattice, shimmering with the eerie stillness of deep space. Most stellar remnants rage with heat or spin violently as pulsars, but this one has crossed into a realm of impossible chill, defying the fiery fate we expect from the universe's graveyard. The physics behind this frozen relic is as mesmerizing as it is rare. When stars like our Sun die, they shed their outer layers and leave behind dense white dwarf cores, Earth-sized embers that glow faintly with leftover heat. Over billions of years, these dwarfs cool, their interiors solidifying into exotic states, but crystallization, that requires temperatures to plunge so low below 4,000 Kelvin that the carbon and oxygen inside begin to behave like metals freezing in a forge. Atoms align into rigid structures, forming what's essentially a celestial latticework, a diamond in the rough of space. What makes this discovery so extraordinary is timing. The universe simply isn't old enough for most white dwarfs to reach this stage. Even the oldest known dwarfs, relics from the cosmos's first stellar generations, are still warm enough to resist crystallization. Yet here in NGC 1277, this star remnant has achieved a state that shouldn't be possible for trillions more years. Some researchers speculate the galaxy's violent history might hold the key. Perhaps the dwarf was born in an early, ultra-dense star cluster where collisions or gravitational interactions siphoned away its heat unnaturally fast. Others wonder if dark matter played a role, its mysterious particles interacting with the star's core to accelerate cooling beyond known physics. Then there's the chilling implication of what this means for the future. If such crystals are more common than we realized, the universe might eventually become a graveyard of frozen diamonds, silently orbiting dead galaxies in a state of eternal stillness. Imagine the far future when all stars have burned out and the cosmos is littered with these glittering husks, the last remnants of a once vibrant universe, cold and perfect, waiting for an observer who will never come. Yet for now, this crystallized star stands alone, a paradoxical jewel in a galaxy of anomalies. It's a reminder that even in death, stars can surprise us, transforming into something beautiful, strange, and utterly unforeseen. And that's the real lesson. The universe has more endings than we've dared to dream. Deep within the swirling chaos of NGC 1277, the galaxy's supermassive black hole isn't just lurking, it's singing. Not with sound as we know it, of course. Space's vacuum carries no acoustic waves. Instead, this cosmic leviathan hums through vibrations in the very fabric of space-time, rhythmic pulses radiating outward from its event horizon like the world's deepest bass note. Detected as subtle oscillations in X-ray emissions, these frequencies form a resonant signature unlike anything else in the known universe, a chorus of gravity itself. The key to this phenomenon lies in the black hole's surface. While event horizons are often imagined as static boundaries, they actually behave more like membranes, able to stretch, compress, and vibrate when disturbed. Matter spiraling into the abyss doesn't vanish quietly. It slams into the horizon at near light speed, creating shock waves that ripple across its surface. These disturbances aren't random, they settle into distinct harmonics, much like plucking a guitar string. The result, a haunting celestial chord with the black hole's mass and spin determining its pitch. NGC 1277's black hole sings in a frequency around 357 microhertz, a tone roughly 57 octaves below middle C, far too deep for human ears but crystal clear to sensitive telescopes. What's revelatory about these vibrations isn't just their existence but what they reveal. Each harmonic acts like a fingerprint, encoding precise details about the black hole's properties. The primary tone, for instance, confirms its staggering mass, 17 billion suns, while overtones betray its spin rate, a blistering 84% of the maximum allowed by Einstein's equations. This isn't just data, it's a direct line into the black hole's violent mechanics. Imagine diagnosing a storm by listening to its winds. The pitch and timbre of these space-time ripples expose forces otherwise hidden behind the horizon's impenetrable veil. The most fascinating twist comes from comparing this song to others in the cosmic choir. Most supermassive black holes hum at frequencies proportional to their size, following predictable scaling laws. But NGC 1277's tone is slightly off-key. Its harmonics shifted as if something's muffling the vibrations. One leading theory suggests the black hole's unprecedented mass might be warping space-time so severely that it dampens certain frequencies, a gravitational muting effect never observed before. Alternatively, the surrounding dark matter halo's uneven distribution could be acting like an acoustic filter, selectively absorbing specific tones. Then there's the eerie absence of dissonance. Black holes with accretion disks, swirling rings of superheated gas, typically generate chaotic overtones as clumps of matter crash irregularly into the horizon. Yet this one's vibrations are eerily pure, implying its disk might be unusually smooth or even fragmented. Some astronomers speculate the black hole's past feeding frenzies could have cleared its immediate surroundings, leaving it to sing in near isolation like a soloist performing in an empty hall. These vibrations aren't just cosmic curiosities, they're reshaping how we study black holes. Traditional methods rely on indirect observations, tracing stellar orbits or mapping radiation from infalling matter. But horizon oscillations offer a direct probe, a way to listen to the black hole's structure in real time. Future gravitational wave detectors could one day tune into these frequencies across the universe, turning them into a new language for decoding cosmic mysteries. For now, NGC 1277's black hole keeps its area alive, a low-frequency testament to the universe's hidden symphonies, and every pulse, every harmonic whispers the same tantalizing truth. Even in the darkest corners of existence, nothing stays silent forever. Raging through the outskirts of NGC 1277, a nightmare of superheated plasma twists into a towering vortex, a cosmic tornado so vast it could swallow our solar system whole. This isn't just hot gas, it's matter ripped apart at the atomic level, electrified particles spiraling at nearly the speed of light, trapped in a dance of destruction by magnetic fields strong enough to crush neutron stars. Seen through X-ray telescopes, the structure glows like a twisted neon sign in the void, its funnel stretching over 10,000 light-years from base to tip, churning with energies that defy comprehension. What makes this plasma tornado so extraordinary isn't just its scale, it's the forces that sustain it. Unlike earthly tornadoes, which fade when their energy source vanishes, this monstrous whirlpool has persisted for at least 500,000 years, possibly far longer. The secret lies in the galaxy's monstrous central black hole, whose jets of charged particles act like a cosmic blender, injecting fresh plasma into the vortex while surrounding magnetic fields coil it into tighter and tighter spirals. Imagine a firestorm fed by an endless supply of gasoline, its flames shaped by invisible hands into perfect, self-renewing helices. Yet the most baffling detail is the tornado's structure. Most plasma phenomena in space are chaotic. Think solar flares or supernova remnants, but this one displays eerie organization. Its outer bands rotate in clockwork unison, while the inner core pulses with rhythmic bursts of gamma radiation, almost like a heartbeat. Some researchers suggest the black hole's spin acts as a metronome, its gravitational waves tuning the plasma's motion into harmonic resonance. Others propose the tornado might be a cosmic scale Tesla coil, with magnetic reconnection events, sudden rearrangements of field lines, acting as natural amplifiers, pumping energy into the system with surgical precision. Then there's the question of permanence. While the tornado's longevity suggests stability, closer inspection reveals its fraying at the edges. Patches of plasma occasionally break free, ejecting mushroom-shaped clouds of ionized matter into intergalactic space. These eruptions release as much energy as 100 supernovas, yet they're mere hiccups to the larger structure. Simulations indicate the vortex could persist for millions more years, unless something disrupts its magnetic scaffolding. A collision with another galaxy, or even a shift in the black hole's accretion rate, might unravel it in cosmic moments, like cutting the strings of a spinning top. What's truly humbling is realizing such phenomena might be universal. If plasma tornadoes can thrive in NGC 1277's extreme environment, they could lurk unseen in countless other galaxies, hidden behind veils of dust or dismissed as instrument noise. Each one would be a natural particle accelerator, a factory for cosmic rays and antimatter, potentially shaping the evolution of entire galactic neighborhoods. And that's the real revelation sometimes. The universe's most extraordinary engines don't announce themselves with explosions or brilliance, but with the slow, relentless twist of magnetic storms older than human civilization. Tucked away in the outer reaches of NGC 1277, an unassuming star flickers with unnatural rhythm, not the steady pulse of a variable star or the erratic flare of a supernova, but the precise geometric dimming of something far stranger. Every 37 hours, its light drops by exactly 23%, not in the smooth curve of an orbiting planet, but in jagged steps that suggest structure. This isn't the signature of a natural companion. It's the kind of pattern that makes astronomers lean closer to their screens, whispering two words that carry the weight of cosmic possibility: Dyson sphere. The concept isn't new, a hypothetical megastructure built by an advanced civilization to harness a star's energy, wrapping it in a shell or swarm of collectors. But seeing potential evidence in the wild, that's unprecedented. The dimming pattern defies conventional explanations. Planets, even those with rings or moons, create symmetrical dips in starlight. Dust clouds scatter light unevenly. This object's blockages are angular, asymmetrical, almost mechanical in their repetition. It's as if someone is methodically turning off sections of a cosmic light switch, one panel at a time. Skeptics point to natural alternatives, of course. A dense debris field from a catastrophic planetary collision could, in theory, create irregular shadows. Or perhaps a swarm of comet fragments, each with wildly different shapes, might pass in front of the star in a way that mimics artificiality, but the numbers don't quite add up. For the dimming to recur with such precision, the debris would need to orbit in implausibly perfect sync, a cosmic ballet with no room for error. Then there's the star itself, an ordinary G-type main sequence star remarkably similar to our Sun. Not too young, not too old, with no signs of the violent activity that might spawn bizarre natural phenomena. If this were a natural occurrence, we'd expect to see similar patterns elsewhere, yet searches of other galaxies have turned up nothing quite like it. NGC 1277's candidate stands alone, a statistical outlier that refuses to fit neatly into any known category. What makes the Dyson sphere hypothesis so tantalizing isn't just the dimming, but the infrared signature, or rather the lack of one. A structure absorbing a star's energy should irradiate heat, glowing faintly in thermal wavelengths. Here, the infrared emissions are suspiciously muted, as if the collected energy is being stored or redirected rather than wasted. Some theorists suggest the structure might be incomplete, a Dyson swarm of individual panels rather than a solid shell, allowing some starlight to escape while capturing the rest. Others propose even wilder ideas. Perhaps the energy is being beamed elsewhere or transformed into something we can't yet detect. Of course, extraordinary claims require extraordinary evidence, and this object is far from a confirmed megastructure. But in a galaxy already brimming with anomalies, it's a reminder that the universe may hold phenomena beyond our boldest imaginations. Whether natural or artificial, this enigmatic light blocker challenges us to rethink the boundaries of the possible and to wonder what other secrets might be hiding in the flicker of distant stars. Floating at the edge of NGC 1277 like an ink blot against the void, Object 30 defies every attempt at classification, a cosmic Rorschach test stretching across nearly 200 light-years. This amorphous cloud of gas and dust contorts itself into new shapes with each observation, morphing from a twisted helix one month to a fractured sphere the next, as if the universe itself can't decide what it wants to be. Unlike the crisp geometries of nebulae or the predictable flow of stellar winds, this structure pulses with chaotic vitality, its edges seething with tendrils that reach outward only to collapse back inward like a living thing. The blob's composition only deepens the mystery. Spectroscopic analysis reveals a cocktail of elements: hydrogen, helium, traces of lithium, but arranged in clumps so uneven they resemble spilled paint rather than the smooth gradients of typical interstellar clouds. Even stranger are the temperature fluctuations. Pockets near the core blaze at over 50,000 Kelvin, hot enough to ionize metal, while outer regions hover just above absolute zero, their particles moving in glacial slow motion. It's as if someone took a stellar nursery, a supernova remnant, and a dark matter halo, then tossed them into a blender set to cosmic unpredictability. What could create such a shapeshifter? One theory points to the galaxy's missing dark matter. Perhaps its absence allows gas to behave in ways gravity alone can't explain. Another suggests the blob might be the aftermath of a near miss between two black holes, their gravitational tides stretching and compressing the cloud like taffy without ever fully capturing it. Then there's the wild card, quantum turbulence. At subatomic scales, vacuum fluctuations occasionally produce tiny bubbles of distorted space-time. Could this blob be a macro-scale version of that phenomenon, a rare instance where quantum weirdness bleeds into the visible universe? The most captivating detail, though, is how the structure seems to react to observation. During one study, astronomers noted its silhouette shifted markedly within hours of being imaged by a new radio telescope array, almost as if it were aware of the scrutiny. Of course, that's impossible, probably, but the coincidence sparked a flurry of playful debate. Is it a gas cloud mimicking life, a glitch in our instruments, or something far stranger? Here's where you come in. Stare into this cosmic Rorschach blot. What do you see? A celestial jellyfish trailing star forming tentacles, the shattered remains of a forgotten megastructure, or perhaps nature's own modern art, a reminder that the universe reserves the right to defy our labels. One thing's certain, in a galaxy packed with anomalies, Object 30 stands as the ultimate inkblot, daring us to find meaning in its beautiful, bewildering chaos. From the oversized black hole bending time itself to the rogue planets drifting untethered through the void, NGC 1277 isn't just a galaxy, it's a cosmic rebellion. Every one of those 30 strange objects we've explored defies expectations, turning this distant swirl of stars into a living puzzle box. Why should a galaxy this size have a black hole so massive it warps the very fabric of reality around it? How can a star cluster exist twice, identical down to the atomic level? And what kind of force freezes an entire spiral arm in place, halting the dance of star formation mid-step? This isn't just about oddities, it's about rewriting the rules. NGC 1277 forces us to ask uncomfortable questions. Are we missing entire chapters of galactic evolution? Could dark matter interact in ways we've never imagined? Is there a hidden order to the chaos, patterns we're only beginning to glimpse? Each anomaly chips away at our assumptions, revealing how much we still don't know. That's the real magic of this galaxy. It doesn't just surprise us, it humbles us. For every answer we think we've found, it offers 10 new mysteries, and that's where you come in. Maybe you've got a theory about that antimatter jet, or a hunch about the quantum fluctuation zone. Drop your wildest ideas in the comments, because sometimes the next big breakthrough starts with a curious mind asking, what if? If cosmic enigmas like this get your imagination firing, don't miss what's coming next. We're diving deeper into the universe's weirdest corners, from galaxies that spin backward to black holes that shouldn't exist. Hit subscribe and let's keep unraveling the cosmos's strangest secrets together. The universe is stranger than fiction, and the best stories are still out there waiting to be told. So what's your favorite NGC 1277 mystery? That crystallized star, the mirror clusters, or something we haven't even discovered yet? The comment section is your launch pad. Let's get theorizing.